Okay, today we're going to learn about solving systems of equations with matrices. One thing you need to know is the identity matrix. It's kind of like just a 1 in regular multiplication. So we represent it with the letter I, and it has to have ones down the main diagonal, and it has to be a square matrix. So it could be a 2 by 2, a 3 by 3, I can make a 4 by 4, but it has to have ones down the main diagonal, and then it has to have zeros everywhere else. So for instance, if you have the matrix A, and on your paper I think you have 5, 7, negative 1, 4, if I multiply that times I, so if I do I times that matrix, if we put this into our calculator or do it by hand, what we'll end up getting is just the original matrix. It's like multiplying by 1 for a matrix or for a regular math multiplication. And the order there could actually go either way in this case. So if I flip it and I multiply the matrix times I, either way, you'll end up with the original matrix for your answer. So that's what the identity matrix does. It just keeps the matrix exactly the same. So our goal for today is to solve equations that look like this. And we want to get this XY matrix by itself. Well, the thing is, matrix division is not a thing. So normally if we had multiplication, you would just tell me to divide by what's in front. But we can't divide by a matrix. So what we have to use is inverses. Similarly, when we had an equation like this and I wanted to get the x by itself, we couldn't divide by the word sign, so we took the inverse sign in order to solve. Well, we're going to do a very similar thing today with inverses of matrices. So the multiplicative inverse matrix allows us to solve a matrix equation to get what's called the variable matrix alone. A couple facts that you need to know: only square matrices have inverses. So if it's not a square matrix, it's not going to have an inverse at all. And a property of matrices is if you take a matrix times its inverse, or the inverse times the matrix, the order here can go either way, what you're going to end up with is the identity matrix. It's kind of like if I take 5 times its inverse, which is a fifth, I would get 1, or a fifth of 5 is 1. Well, when I take a matrix and multiply it by its inverse, I get the matrix form of the number 1. So what I want to do here is decide if these matrices are inverses. So I'm going to just pause the video and I'm going to type these into my calculator real quick. Okay, so I just typed these into my calculator. So I have the first matrix here times this second one that's on your paper. And I'm going to go ahead and hit enter and see what I get when I multiply them together. And you can see what I end up with is the identity matrix. It has the ones right down the main diagonal. So that means that, yes, they are inverses, and that's because when I multiply these together, I end up with the identity matrix. Okay, now we need to know, well, how do you find a matrix inverse if it is even defined? So on our calculators, I would like you to go through this with me. So if you could please grab your calculator. We are going to put in this first matrix, and so I'll go to Alpha Zoom. I need a 2 by 2 this time. And I'm going to put in 4, 3, 2, and then 1. And the way you get the inverse is you hit the little x to the -1 key. That key tells the calculator that you are looking for the inverse. So you go ahead and hit that, and then there is your answer. So again, you use the little -1 key, and the answer is -1/2, 1.5, 1, and -2. Okay, so now I'm going to try this next one. So let's come over here, Alpha Zoom, in order to get my, in this case, 2 by 2. Remember, they do have to be square matrices in order for you to be able to do this at all. So if you had a matrix that was not a square matrix, there would be no point even doing this. Right, so I put in everything, and now I want to find the inverse, so I hit the x to the -1 key, and I hit enter, And in this case, you get singular matrix error. So what that means is that this one has no inverse. Basically, that means that if these were lines that we were graphing, they would be parallel lines. So that's kind of what causes that to occur, but that matrix does not have an inverse. Okay, so here's how we go about solving a matrix equation. What we are going to do is set it up so that it goes x plus y equals number. So that's what you've got to do first. It's got to be, these variables match, and then these variables match, and then numbers. And what we're going to do is we're going to take the coefficients, so the numbers out front, that's what's going in this matrix, which is called the coefficient matrix. Then we put the variable matrix, so it goes in order this one, then this one, so column-wise x then y. And then this is called the constant matrix. So you take this, and that's what's going to make the constant matrix. So what I'm trying to do is take a times x to get b, but again, you're not able to just divide by a. So what we're going to do is take the inverse on both sides. So we're going to multiply both sides by the inverse of a. And we know when you multiply an inverse times a matrix, you end up with the identity. But the identity times anything is just the x matrix. So this is going to be my variable matrix. So to get the answer, I need to take the inverse of a times b. So you're going to take the inverse of the coefficient matrix times b. Right? So let me show you with an example kind of going all the way through here. So first of all, I check it does go x, y number, so we're all set. First thing I'm going to do is make my coefficient matrix. So my coefficient matrix would be 2, 5, 5, and -3. And then times the variable matrix, which would be xy. And that is equals the constant matrix of 0, 31. So what I need to do from here, in order to get xy, I need to undo this. So I'm going to multiply by the inverse of that on both sides. On the left side, it'll just cancel out. So I'm going to take the inverse of this matrix times the constant matrix. So on my calculator, and please do this with me on the calculator, just for the practice, we're going to do alpha zoom. Oops, sorry, I have a marker in my hand here. Okay, so I'm going to go ahead and do a 2 by 2 matrix. And I'm going to take the first, so 2, 5, 5, -3. Take the inverse of that, and then multiply that. Go to my alpha zoom again. This time I need 2 rows, but only 1 column. And then I'm going to put in my constant matrix, which is the 0, 31. So again, I take the inverse of the coefficient matrix times the constant matrix, and I get the answer 5, -2. So that means that xy is equal to 5, -2. So of course that means x is 5 and y is -2. And if you check that really quickly, like if I use this one, 2 times 5 plus 5 times -2, you can see 10 minus 10, that does in fact make 0. And if you plug those numbers into the other equation, you will also see that those make 0 as well. Sorry, I mean in the other equation, it'll equal 31.